Grid, Snug, Organic. Which one is correct? Well, obviously that's a trick question. These are 3 different kinds of support material you can use in PrusaSlicer, but often people ask me which one is best for my application. And I get it, it's very confusing, especially with the recent introduction of organic supports, which look amazing, but spoiler alert, they're not the best for every application. So in this video, to follow up on the recent video I did on different supports from different slicers, I'm gonna be talking about these 3 different support types in PrusaSlicer and how you can use them best to power your 3D prints. Let's get started. Support material for consumer level 3D printers has come a very long way. I used to always say in the past, avoid it at all costs because it's a pain to remove, it welds to the print and ruins it, and it's best to modify your files as much as possible to not need support material. And that is still very, very sound advice. But some objects just need support material to print. It's as simple as that. You don't want to limit your creativity because a print needs support material. You want to use the best support material possible so it prints correctly and you can remove the support so you have the final object you want. But how do you do that best in PrusaSlicer? Now there's 3 different kinds of support material. Well, I grabbed the Geyer Anderson cat and I cut its head off, scaled it up, and I tested the 3 main support material types to get a good idea of how they look and how they work. And we'll start with grid because this is a support material type that most people will just use by default and they'll never ever change. And that's mostly okay. It's a fairly reliable support material that can be removed easily from most 3D prints, but it's far from the best option. So here I have the Geyer Anderson cat head sliced with grid supports. I've changed the settings to 25 degrees of overhang threshold, so it's not supporting a ton of the print, but it's enough to make the print succeed. And this is the default result using those settings. So if I go down to the bottom and start going up, you can see these columns and this bed of support that forms to hold our print in place. Now, instantly, you can notice a few problems. The front bit is okay, but look at the face. Now, straight away, we can notice a couple of problems. For a start, these columns here, where the ear hole is. So these supports, their only job is to support that hole in the ear that really doesn't need to be supported, but also to do that, it's building these very, very thin columns of support material. Now, they do have brims, and that's this little platform at the bottom that gives it better bed adhesion. These would always fall down without that extra little bit of help. But even now, with that brim, you can see how thin they become. They can break away very, very easily if your nozzle knocks them during printing. On the other hand though, the front of the cat here has this bulk of support material that's going to be a little bit difficult to remove because as you see, as it's building up, it's actually quite strong. These sections here all come together in this dark gray area, which is known as dense support or the interface layer. Without the interface layer between the model and the support material, you'd have areas that aren't very well supported and you'd get overhangs and you'd have to remove these little lines of support from the print. Again, back in the day you had to do that and it sucked. But here you can see it's actually supporting the bottom of the cat very, very well. But as it goes up to the eyes, you can see what's happening here. It's actually starting to build support on the model itself, which isn't really desirable because you're going to end up with a blemish there where the support material isn't needed. It's just trying to print support material to support this area. But because grid support is purely vertical, it can't deviate, it is forming on the cat's face here to support the eyelid here. Now, you can disable this behavior by going back in and ticking support on build plate only, like this. However, if you do have areas above other areas of the model that need support, then they're going to fail. This is a very dumb check. It's essentially saying, once the model is forming, I'm not going to put anything on top of the model. So for example, it's not trying to support the ears anymore because the support material would have to interact with the head there. It's not trying to support the whole eye, but it's trying to support just the edge because the cat's little nose is here and it's trying to avoid it. Support on build plate only is great, but only if you've designed the model in such a way that you know it can succeed with that mode ticked. Otherwise, you generally have to print with it unticked and you have a lot of material to be removed. So grid support sucks, right? Well, no, not at all. I actually use grid support a lot for models that have very flat overhangs or models that have underside facing sharp edges. You can see that this model actually has this overhang here, this underside sharp point, and they are notoriously hard to support properly. So what I've done is I've actually gone into support painting and I've told the slicer that I want this point supported really, really well. and this underside edge as well. And what that's resulted in is this little sort of cradle of support material. So you can see this really nice column forms, and then this little bit of dense support forms, and this little like cradle supports the point. This actually gives it a lot more support and rigidity as it's forming, but I find that grid supports printed like this break away very, very easily and very, very cleanly, and I do use them for this sort of print all the time. Next up, we have snug supports. Now, in my last video talking about different support types and different slicers, people said in the comments, why didn't you test snug supports in PrusaSlicer? And I'll be honest, I hadn't used it a lot, so I've been playing around since that video to get an idea of what it's good for, and again, what it's not so good for. So again, here we have the cat with the same overhang settings, but now we've changed from grid to snug. And you can see that it's less support material, but it's going to be more difficult to remove in this case. So if I scroll down to the bottom, this is our support structure for snug. It's actually got a lot of disconnected points. It's not a uniform grid. There's this tiny little column here, and that's like almost guaranteed to be knocked over because it's trying to support just this one little point here, and then the support will build on the part itself. So for example, on the cat, to try to get those eyes there. In this case, snug is a terrible choice because you can see in the ear hole where the earring is, it's just, you're gonna have to use a pick to knock that out. But I found with a little bit of tweaking, snug works really, really well for large underside curves that really struggle with regular support material. Let me show you an example of that. This is a large spiral wheel for a project I'm working on, and there is no good way to print this. You can see the bottom has this huge curve here, there's these nasty overhangs, and then the top has these sharp points. So there's no easy way to print this. So what I've done is I've used snug supports, you can see snug here, but I've also used support painting, and I've told the slicer that I really want to support the edge of this spiral here. Up to this point only, but I really want to support it that much. Check out the results using snug supports. These supports are super sturdy. You can see that as the part forms, there's a little bit of that dense interface, that interface support that's coming up between the part and the support material itself as it forms up like this, and it's perfectly supporting this spiral as it spirals up. Now, I don't need to go any higher than this because I'm printing at a layer height of 0.15, and by printing at that layer height, it means that there's enough step over between each layer, as you can see here, that it actually prints okay without support. But obviously we need to support it on the print bed, which is where that these snug supports work really well. Now, if you had a model where you'd struggle to get access to this support material, yes, it's not a good choice because it's quite strong actually, and it's difficult to remove from a more delicate model. But with this print, it holds it in place perfectly during the printing process, but afterwards, it just snaps away so beautifully, and it's a perfect example of how to use snug supports. And I can show you with grid that it's just not as good. So if I go to grid and do the same settings, exactly the same, you see that grid has this weird tendency to kind of extend over the model and leave these little artifacts here. And you even see the interface layer isn't as good. It's okay, but it's not going to leave as clean a result as the snug supports. So I really like to use them for models like this, where you can paint on really, really strong columns of support on weird curved surfaces where you know it's going to hold them really well. But afterwards, you just tap them off, they break away cleanly. This video was sponsored by MicroSetter, which is your one-stop shop for all things Maker, like this Inland PLA Plus that I've been using for all the tests in this video. And they just sent across 2 new crazy 3D printer deals that I have to share with you. For new customers in-store only, you can now pick up an Ender 3 V2 for only $99, which is a super affordable way to get into 3D printing. But they also have a new coupon for the Creality Ender 3 S1 for $199. The S1 is one of my favorite Ender 3 variations because it has a direct drive extruder, which lets you print a huge range of different filaments compared to Bowden, and it comes with a 32-bit control board with silent steppers. It's got to be one of the best 3D printer deals going right now, so head to your local Micro Center, and a reminder that they're opening up a new one in Indianapolis this summer. You can find information in the video description. And then last, but certainly not least, is organic support material. Now, this is the latest and greatest thing in the Prusa 2.6 Alpha, and you currently can only get it in Alpha. This is Alpha 6. They're releasing new ones every few weeks, and this is why they are so groundbreaking. Like before, I said with this cat head, that to support the ears and the eyes, the support material had to come up through the model, so it was building up on top of the nose to support those areas. But organic supports can curve, so you can see here, they're actually curving around the periphery of the model, right on the edge. You can see it's curving up around to support that eye, and it's curving up around to support that earring hole. So the model's surface isn't being damaged by support material. The support is actually curving around to meet the areas that it's needed, but without touching the model. And that's really, really groundbreaking. It's why it looks so tentacle-like and strange. Now, other slicers have had tree supports for ages, but what I find different between these and tree supports is their reliability. So if I scroll down, you can see how they've actually done the algorithm. They start with a really large brim, which helps with the bed adhesion. And then as they build up, they're hollow, but they branch. And as they branch into areas that need to support the part. And then instead of doing like a dense fill, the branches actually start to part away just as the model is forming to sort of cradle it in place. And for areas that have just a point of contact needed for support material, it'll just do literally that. It'll just do a point. So for example, here it's just reaching around and doing little into the earring, just like a little bridge like that. The eye as well is a good example. You can see that just as it builds, it makes a little point here and then keeps going. Now you could argue that it's not really necessary here. I printed a lot of Gator Ants and cats that don't have support material for the eyes like this, but considering how easy this is to break away, why wouldn't you do it? The only downside is it's a little bit fragile compared to grid or snug supports if you have a large density of it, because it makes all these branches around the model that may be knocked down. Now I haven't tried really, really big models with organic supports where it may fail. They've actually been really successful for me so far, but I'd love to hear your thoughts and experiences in the comments below. And similar to the Gator Ants and cat, this fox by Photos Mint is a prime example of where you would want to use organic supports. It is good for organic models, which have certain points of overhang that you don't want to ruin the surface finish by building up from the model into. So you can see here, there's certain areas on the face of the fox that it would normally have support material on the model getting to that point, but because the organic supports can curve, it's trying its best to go around and contact those areas. There is one small downside to organic support that I've noticed so far, and that's that it's very computationally intensive, depending on how complex the model is. Because it's making all of these branches and stuff, it's not as straightforward as, lay a grid, build it up to where the part needs support, then stop the grid there, which is how all the old sort of support materials algorithms worked. Here, it's actually forming these branches that will branch around the model and come back and support those overhangs. So it's a lot more computationally intensive, but it does work quite well. And it's really changing the way I think about support material, because normally, as I said, I'd try to avoid support material forming on the part because I need to support a surface above it. So I'd normally try to do support on build plate only and modify my design. But here you can see with organic supports with this spiral, now I'm not going to print it like this because it doesn't need to be, and it's going to take way longer to print than my previous arrangement with snug support. But you can see that it actually would be quite good. It's not touching the top surface of the model, it's only touching the underside overhangs where it's needed. And it does this crazy branching where it branches and branches and then forms this flat surface that the model can use to build on as it builds all the way up to the top. And there you have it, the 3 different types of support material in PrusaSlicer 2.6 Alpha and how I like to use them in their different applications. I'd like to hear in the comments below how you guys use support material in this latest version. How have you found organic supports? Have they been really, really groundbreaking for you, or have they been kind of frustrating for you? I'd love to hear your thoughts in the comments below. And if you want to learn how to remove the need for support material entirely, my latest ebook has a whole section on design tips and tricks you can use to remove the need of support material before you even get to the slicer, so you don't even need it at all. It's full of heaps of different tips I've picked up over the last 10 years I've been involved in 3D printing, and you find it linked in the description below. Thanks for watching, guys. Bye.